Okay, to start off this video, we're going to go over the challenge problem from the last video. So to start with a free body diagram, we have our normal force, F sub n. We have the force of the Earth on the sled, which is just represented by a dot, and all that means is it's the center of mass of the sled. And then we have a force of friction. Alright, and then part B, we want an equation for the force of friction. So we're going to start by summing the forces in the direction of motion, which is the x direction, if you remember our tilted coordinate plane. Right, where this is our x-axis and that's our y-axis. So if we sum the forces in the x direction, calling direction of motion positive, we get the force of the Earth parallel minus friction equals ma, and because we have a constant velocity, acceleration is 0. So that means the force of the Earth parallel to the sled equals the force of friction. Now, if you remember, the force of the Earth parallel to the sled is just mg sine theta because sine slides. And that is the answer for part B. Alright, so here's our first free response question. So we want to find the acceleration of the 2 kilogram block, which will then be the acceleration of the entire system. So we can solve this problem, you could say the easy way. Using the more difficult way, especially with the this many blocks, will be very difficult. So we want the net force acting on the system. So that is going to be, we would say, the 4 kilogram block. So let's just start by giving them numbers. This will be 1, 2, and 3. So we'll take M3G, calling this positive, minus M2G minus M1G divided by M1 plus M2 plus M3. Alright, you could pull G out, so then you would have 10 times 4 minus 2 minus 1 divided by 4 plus 2 plus 1. And that will give an acceleration of approximately 1.429 meters per second squared. Alright, now we want the tension in the string between the 4 and 2 kilogram blocks. So to do that, I'm going to start by drawing a free body diagram for our 4 kilogram block. So you're going to have a force of tension up and a weight force down. Notice that the weight force is larger than the tension force because the block is accelerating downwards, so tension is less than its weight. So we sum our forces on block 3, and I did choose block 4 because block 2 would be more difficult, if not impossible, with those 2 tensions and its weight. So we'll take mg, because it's in the positive direction, minus tension is going to equal m3a, and then tension will equal m3 times g minus a. So that'll be 4 times 10 minus 1.429, which approximately equals or actually exactly equals 34.284 newtons. Alright, now for part C, we want the tension supporting the 1 kilogram block. Since that is our block of interest, let's start with a free body diagram. So we've got that tension up and that weight down. Alright, so now we're going to sum the forces on block 1, and that will be tension minus M1G equals M1A, and then tension will equal M1 times G plus A. So the idea here is that block 1 is going to be accelerating upwards. In that case, tension has to be greater than its weight, so we'll know, or we'll have a pretty good idea if we have the right answer if the tension is greater than the weight of block 1. Because if tension was less than the weight of block 1 would be accelerating downwards. So we'll take its mass of 1 kilogram times 10 plus an acceleration of 1.429, and that gives us a force of tension of exactly 11.429 newtons. That is greater than the weight of block 1, so we should feel pretty confident in that answer. Alright, here's the final problem for this video. So we've got two blocks of equal mass connected by a massless rope about a massless and frictionless pulley on a smooth tabletop. That just means there's no friction, or friction is negligible, and the blocks are released and falling. Alright, so we want to know in terms of h, m, and g the acceleration of the blocks. Well, hopefully you've got the hang of this by now and can do it on your own and get the right answer. So we'll just take the acceleration of the system. Alright, so what is making the system go? That would be the weight of our hanging block. So mg divided by the total mass of the system of 2m, because the m's are equal. M divides out, and the acceleration of our system is g over 2. And then second, we want to know the time at which block B hits the floor, assuming it doesn't bounce. Alright, so we've got some kinematics to do. Let's start with a little chart. Our initial velocity is 0. Our final velocity is unknown. We know acceleration is g over 2. And we want to solve for t, where h, or I should rather say our change in y, is just y. You can tell that from the diagram. So we want an equation without final velocity. So that's going to be delta y equals initial velocity times time plus 1/2 at squared. Alright, initial velocity is 0, and that's something you should always do on the exam, is write out your equations. So this is 0, or that looks like we're dividing by 0. Anyway, we can say then that y equals 1/2 times g over 2 t squared. Actually, you know what? Let's solve for t first. T equals 2 change in y divided by a square root. And that is just 2y divided by g over 2. Square root, which you can say equals, if you multiply the numerator and denominator by 2 square root of y over g. Alright, and actually, let's do part A the challenging way, because that was quite easy, and for doing the AP exam and it's a reasonable request, I'd say show all the work. Alright, so we're going to sum the forces on block A, which will give us T equals MA, and we can sum the forces on block B. Let's find this to be our positive direction. That will give MG minus T equals MA. Substitute in T, and that will give MG minus MA equals MA. M's all cancel. G equals 2A. Or you could say acceleration equals G over 2. You get the same answer either way, but this way would get you all your points. Part C is the last part to this question. We want to know the landing distance between the two blocks. So what's going to happen is that block A is going to accelerate across the table as block B falls, and eventually it's going to leave the table and travel with a constant horizontal velocity until it reaches the ground some distance from B. And we want to determine that distance. So we know that distance equals velocity times the change in time. Alright, we need to find V and change in T. So the velocity of block A when it leaves the table is going to be equal to its initial velocity, which is 0, plus the acceleration times some time t. And that time t is the time it takes for block B to reach the ground. So basically, we need to take G over 2, that's going to be its acceleration across the table, because that is the acceleration of block B as it is falling, times 2, and I'm going to rewrite our TB as square root of y times G to the negative 1/2. So the reason I'm able to do that is that we can rewrite this as 2 square root of y over square root of g, and 1 over the square root of g is just g to the negative 1/2. Alright, so these 2's will cancel, and this is g to the 1 plus g to the negative 1/2, which is just equal to square root of y times the square root of g, because it's just g to the 1/2, if you remember your exponent properties, and that will just be the square root of y times g. Alright, so that is our final velocity, so we can plug that into this equation, square root of yg and now we need to determine the time it takes for A to hit the ground. Alright, my handwriting is not doing very good today, so we've just got YG. Alright, so I'm going to make a kinematics chart for this. So in the x direction, we know that velocity is constant, and it is the square root of yg. We know acceleration is 0. We are solving for delta x. actually, you know, we don't know delta x, so that's just going to be a question mark. We're solving for delta t right now. Delta x is the ultimate goal. So we're going to put 2 question marks there since we're solving for that. In the y direction, our initial velocity is 0. Our final velocity, we don't know. Our acceleration. Alright, so at this point, block B has hit the ground and block A is in free fall, so its acceleration is just going to be g. Our change in y is 2h, or I should say 2y, and our delta t we are solving for. So we can just use this with our y table. We need an equation with no final velocity, so that would be delta y equals initial velocity times time plus 1/2 at squared. This here is 0, so then we can say that t equals 2 delta y over a square root, that's going to be 2y over g square root. Okay, that's the time it's going to take for that block to hit the ground. So let's make some more room and we can solve our final piece of the puzzle. Do not want to move that. Okay, that should be good. This is going to be times square root of 2y over g. Hey, hang on, I made a mistake here with this part. We have delta y equals 1/2 at squared because initial velocity is 0. T equals square root of 2 change in y over a, and that's equal to the square root of 4y because our change in y is 2y divided by a. Alright, and that gives 2 square roots of y over g. So this 2 should be outside of the square root. And then clean up a little bit. Alright, so now we multiply this out, and that is going to give 2 square root of y times y g over g, which gives 2 square roots of y squared, which gives 2y. So that means the blocks are going to land a distance of 2y apart from each other, which is the distance that, the vertical distance that block y falls to hit the ground. Alright, so that wraps up this video, and I'm not going to do a challenge problem for this video because it's the end of a unit, and I think you all deserve a break. Our next unit will be on circular motion, and that will be followed a little bit with some gravitation.